Hey everyone, today we're going to be talking about the linear probabilistic model. One of the reasons we like this model is because it can be easier to calculate when compared to something like the logistic model. And it also is easier to interpret, which is very important when we're talking about statistics, especially when we want to show and present them to other people. Here we have the basic formula of the regression line, which is y equals beta sub naught plus beta sub 1 times x plus epsilon. Epsilon is very important because it allows for the points to fall above and below the regression line, which is what makes this formula good and different. Beta sub naught is the base probability, and beta sub 1 is the probability of the dependent variable. But overall, the basic definition of the linear probabilistic model is that it models data where the expected value of y is a linear function of x, which is shown through this line that we draw through our points, which is the line of the mean value. And here we can see that the epsilon sub naught is below the line of regression, which means that it is less than 0, and the points above this line are greater than 0. Here we have a little bit more of a firm example, and I kind of left it open-ended so that you can just look at the points and how they work. But one example that we find a lot in engineering is the number of defects, which is found along the x-axis, and then compared to the total number of parts along the y-axis. Now, we do have a couple outliers in this example, but overall they stay somewhat close to the mean line. But so one thing that we want to keep in mind is that we want the random error to be as small as possible so that it makes it more accurate. Something else we want to consider is why we are using something like the linear probabilistic model. One of the main benefits is that the points are it is more open to different sets of values when compared to something like the logistic model. Like the points usually fall between something like 0.2 and 0.8, whereas something with the logistic model, they're either close to 0 or close to 1, which isn't as easy to interpret as something like the linear model, which is again good because when we're presenting our data to our bosses, for example, when we get into our fields, it is easy to follow and understand.